Hi everyone, welcome to AI Connect channel. This is Akash Kumar and today we'll be studying circles lecture 5. So we'll be talking about chord of contact, chord with a given point and pair of tangents in this particular lecture. And we are going to do all in terms of notations only. So from now onwards and basically from the previous lecture you have to just understand the notations and your entire question would be done. Your entire concept would be done. So notations are quite important in terms of circles and you'll have to use the same kind of notations in the other conics as well. So yeah, if you understand these notations in circles, you can apply the same kind of notations in parabola, ellipse, hyperbola. Okay. So let us start a discussion of chord of contact. From any external point, two tangents can be drawn to a given circle. The chord joining the points of contact of two tangents is called the chord of contact of tangents. So it says that we have one particular circle and we are dropping two tangents from an external point P, and the chord drawn through these 2 points would be called as chord of contact. These points are actually the point of uh, basically this particular tangent is touching at this point and this particular touching the circle at this point. And if you join these 2 points, we are going to get a chord, and that chord is called as chord of contact. Okay. Now again, we are going to use the notation t equals to 0 over here. We use the same notation for tangent, but the difference over here is we are using x1, y1 as this point. So let's say if this circle is x square plus y square equals to r square. Let's say this circle is this sand circle. Okay. In this case, we are going to do the transformations. Transformations would be x square goes with is replaced by x1, y square is replaced by y1, right? We don't have any x and y terms, so we'll do these two transformation this particular equation and we'll be getting x1 plus y1 equals to r square. Now this x1 and y1 over here is this external point. Now we are writing the t notation. This is the t notation only, but when we are writing this t notation, we are using this particular x1 y1, that is the external point. In case of tangent, what we used to do, we used to use this particular point x1 and y1. Okay, so when we are using the point on the circle, that would give us tangent. When we are using the external point, we are going to get the chord of contact equation. So this equation would give us the chord of contact equation. Now you can also visualize this in this particular manner. If I move this point towards the circle, I'll be getting the tangents like this, and basically chord of contact would shift. If I move this point over here, I would be getting tangents like this, chord of contact would shift. If I move this point on the circle, I'll be getting chord of contact as a tangent only, right? So that is why this notation is becoming same for both the cases. So in this case, t equals to 0. If you are using x1 and y1, we are going to get chord of contact. If you are going to use x1, y1 on the circle, we are going to get the equation of tangent. Okay. Now let's look at this question. The chords of contact of the pair of tangents drawn from each point on the line 2x plus y equals to 4 to circle x square plus y square equals to 1 passes through the point a comma b and find the value of a by b. Now the keywords over here are chords of contact, not just chord of contact, chords of contact and passes through a point. Basically, these chords of contact are passing through a fixed point, that is a comma b. Now this kind of statement would give me the idea of family of lines. Okay, line 1 plus lambda times line 2 equals to 0. I would get this kind of feeling based on these two statements. So let's see how do we solve it. So now we are talking about chord of contact. So basically, eventually we have to use t equals to 0. Okay. Now chord of contacts of a pair of tangents drawn from each point on the line 2x plus y equals to 4. So basically there is a variable line over here and there is a circle and we are drawing chord of contacts from this particular line. Okay, so we are drawing multiple chord of contacts and basically all those chord of contacts are passing through a particular point. Okay, now let's say that point is a comma b as given in the question. That point is a comma b. Now since this is a variable line, so this will be having variable coordinates. So if this is x, so y would be 4 minus 2x. So let's say this is alpha, this would be 4 minus 2 alpha. Okay, or you can say lambda, 4 minus 2 lambda. Okay, now since this point is given, we can write down the equation of chord of contact with respect to this point, right? That would be x1 plus y1 equals to 0. So x1 over here is lambda plus y1 over here is 4 minus 2 lambda equals to, not equals to 0, equals to r square. R square equals to 1 over here. okay, equals to 1. That would give me lambda x plus 4y minus 2 lambda y minus 1 equals to 0. So if I take lambda as common over here, I'll be getting x minus 2y, and that would become 4y minus 1 equals to 0. Now this has become actually the format of this line 1 plus lambda times L2 equals to 0. This is line 1, this is line 2, and lambda times L2 equals to 0. Okay. So basically y equals to 1 by 4. And if I put the value of y over here, I'll be getting x equals to 1 by 2. Okay. So our a value is 1 by 2 and b value is 1 by 4. So we'll be getting 2 as the answer. Okay, 2 is the correct answer. So the concept was pretty clear that we have to use chord of contact. Basically, we have to use t equals to 0. The line is given, so we have to take variable point. And since it is saying that these chords of contact are passing through a fixed point a comma b, that gives us the hint of aligning our thought process towards the family of lines. Okay, so that is how you have to do this question. Now let's look at the next concept, that is chord with a given midpoint. Now again, we'll be using the notation over here. So we have this particular chord and this midpoint is x1, y1. Okay, this is the circle. Now the notation for this is t equals to s1. Now t is written corresponding to x1 and y1 over here. So until now we have studied t for three concepts. The first one was tangent and the point was on circle. That was t equals to 0 for this point. The other one was chord of contact, where we have written t equals to 0 for this point. Now we are talking about chord with a given midpoint, and again we are using the t. We are not using t equals to 0, we are using just t equals to s1. But when we are writing t, x1 plus y1 minus r square, we are using x1 and y1 as the midpoint of this given chord. Okay. So S1, you already know, we have to write S1 corresponding to this particular point, and we have to also write T corresponding to this particular point. So that would be, let's say this circle is x square plus y square minus r square equals to 0. So T would be x1 plus y1 minus r square, and that would be S1. S1 would be x1 square plus y1 square minus r square. This r square gets cancelled out. So we are getting x1 plus y1 equals to x1 square plus y1 square. Okay. Now let's solve this question. Through a point a comma b, secants are drawn to the circle x square plus y square equals to r square. The midpoints of the corresponding chords describe the curve. Again, we are talking about midpoints of the corresponding chords. So basically, we have to use t equals to s1 over here because we are talking about chord with a given midpoint. Chords with a given midpoint. Okay. So we have this circle and we have this point a comma b over here, given point a comma b over here, and we are actually drawing secants from this particular point onto the circle. Every chord is having a particular midpoint, and we have to find out the locus of this curve. Okay, whatever is it's forming. Now basically we have to use chord with a given midpoint. So given midpoint, we can assume it to be h comma k because that's what we assume in locus, right? So we have to write the equation, basically notation equation t equals to s1 with respect to this particular point. So x1 and y1 over here is h comma k. Okay. So t would be for this particular circle, t would be x1 plus y1 minus r square. Now that would be xh plus yk minus r square, and s1 would be h square plus k square minus r square. If I equate both of them, I'll be getting xh plus yk equals to h square plus k square. Now we know that all these secants, basically we have written down the equation. We have written down the equation of all these secants. Basically all these chords. These chords are nothing but secants only. All these secants are actually passing through this point a comma b, right? So we can put the value a comma b on in place of x comma y. Okay. So that would give us ah plus bk equals to h square plus k square. Now we can replace h and k with x and y to get the final equation of locus. That would be ax plus by equals to x square plus y square. So this is the locus equation for this particular problem. Now let's talk about pair of tangents. So this is again a notation based concept. So we are actually drawing two tangents and we have to find out the equation of these pair of tangents. Not just one tangent, we have to find out the equation of pair of tangents simultaneously. Okay, so how to do that? For that we'll be using S1 equals to t square. Okay, we have to write t corresponding to this point x1 y1. We have to write s1 corresponding to this x1 and y1 point, and s is the just expression. So let's say this circle is x square plus y square minus r square equals to 0. This is the circle. So expression is this only, right? S expression is this only, x square plus y square minus r square. So our notation would give us x square plus y square plus r square times s1, that would be x1 square plus y1 square minus r square, not plus over minus r square, equals to t square, that would be x1 plus y1 minus r square whole square. So this we have to solve to find out the pair of tangents equation from this particular point onto the circle. Again, it's quite simple. Now let's look at this question. Find the equation of tangents to the circle x square plus y square minus 6x plus 8y equals to 0 from the point 0, 1. Okay. So that's a fairly simple and straightforward question. We have to just demonstrate it once. So this point is, let's say 0, 1, and the equation of circle is x square plus y square minus 6x plus 8y equals to 0. And we are drawing two tangents from this particular point onto the circle, and we have to find out the pair of tangents over here. So we'll be using S1 equals to t square notation. So S would be x square plus y square minus 6x plus 8y only, right? This is our S. S1 would be, basically we have to plug this point in this expression. That would be 0 plus 1 minus 0 plus 8. So that would be 9. So S1 equals to 9. And T would be over here. T equals to x1 plus y1 minus 3 times x plus x1 plus 4 times y plus y1 equals to 0. Not equals to 0. So we have x1 over here as 0. So that would become 0. Plus we have y times y1, that is 1. And we have minus 3 times x plus 0 plus 4 times 1 plus 1. Sorry, y plus 1. Okay. Now this becomes y minus 3x plus 4y plus 4. So this becomes 5y minus 3x plus 4. This is our t. Now we have to use this expression SS1 equals to t square. So SS1 is 9 times x square plus y square plus minus 6x plus 8y. This is equals to 5y minus 3x plus 4 whole square. Now you have to just square it and you will find out the equation of pair of tangents. So that's a bit of a more calculative part and not the very conceptual part. Only thing you have to remember that while finding out the t value, you have to put this particular point. Okay. So this lecture was till here only, and we'll be talking about the further concepts that are not a part of syllabus in the next lecture. And let's meet tomorrow. Thanks for watching.